Yes, hi guys. So today I have to talk about further with the help of test. There are certain tests which one or two tests I have already discussed in the previous lecture. In that lecture, comparison test I have discussed about quotient rule, or quotient test, which I have not discussed. But even then, I have described that in the description of the previous lecture. Please, if you want to see the quotient test of comparison of convergence of two functions, then you have to see the description of my previous lecture. But let me today describe that also again. So I'll describe quotient rule or quotient test, or the quotient test for or comparison test in case when two functions are in quotient form, division form, or in ratio form. That I'll discuss today. And then ABEL'S test, which is very important for multiplication of two functions. Similarly, Dirichlet's test, Dirichlet's, and that I've discussed. About Dirichlet, I've already discussed in multiple integrals. In multiple integrals or definite integrals, I've discussed who was Dirichlet and what was Dirichlet's theorem in that case. And so, introduction about Dirichlet's biography, I'm not going to discuss about. That I've already discussed. Please see that if anybody wants to know about who was Dirichlet and by the mathematician, from which country, and when he was, the time of his living, his period of discussion or period of his studies, what was the time. So that if anybody wants to see, that can be seen in the previous lecture, one of the lectures of mine, where I've discussed multiple integrals. So multiple integrals I've discussed, and there I discussed about Dirichlet's theorem, so for multiple integrals. Now, today I'll discuss about Dirichlet's test also. So Dirichlet has contributed a lot of things. Similarly, ABEL'S test. Now, Abel, who was Abel? His name was Niels Henrik Abel. Niels Henrik Abel was very great mathematician, and he was very good person. Born premature. His birth was premature, but he was so intelligent. That person was described as one of the giants of the mathematics. And his contributions are so many that one of the mathematicians from France, French mathematician, once described that Abel has given so much in the field of mathematics that is sufficient for mathematicians for 500 years. If mathematicians are discussing about the contributions of Abel, then they will not find, they will find 500 years even less to discuss about his contribution. So that is so much he has given. But he died premature. His age was only 26 years and 8 months. That was premature. He was born in 1802 and died in 1829. In 6 April 1829 he died, and born on 5th of August 1802. That was his period of working. But the person was mathematician. He was from Norway. A Norwegian mathematician, very brilliant one. In his name, 4 coins are issued in his name. In his century year. So a lot of contributions he has given from Norway. Norwegian mathematician, very good mathematician. He has contributed a lot, which no a single person in his lifetime has contributed to know. But he contributed only within the working of 6 to 7 years. He died after 26 years and 8 months, but only he worked for 6 to 7 years. So in that period, he has contributed a lot in the field of mathematics. That is immemorable thing which he has contributed. Abel's theorem, Abel's test, Abel's binomial theorem. A lot of things. Abel's group, Abel's irreducibility theorem. A lot of things are there. So he has contributed a lot. A number of things he has contributed. Even in definite integrals, in convergence, so convergent test. I'm just going to discuss about ABEL'S, who was Abel. Then I'll take these questions one by one. These questions are based on ABEL'S test, quotient test as well, multiple test or multiplication of two functions. That also I'll discuss about mu test, which I have already discussed, but I'll discuss that again also. So mu test is also described here. So convergence of improper functions. This is first kind of improper functions I'm going to discuss about. First kind means when limits are infinite, a to infinity, or minus infinity to plus infinity, or minus infinity to b or a. Okay, that means when limits are infinite and integrand is bounded, okay, or is continuous, that means the first kind of improper integrals are there. So improper integrals are convergent. For that, there are tests which I am going to discuss. So let me discuss about those tests. First test today I have to discuss. Okay, let me first discuss what is quotient test, which are described in the description of previous lecture. And let me discuss quotient test also. Or let me first take ABEL'S test, okay, which is very important. Who was Abel? Let me first biography. What is biography of Abel? His name was Niels. Okay, Niels Henrik. Okay, Niels Henrik or N-E-I. I'm sorry. This is N-E-I-L-S. Niels Henrik Abel. It is his complete name, by the Norwegian mathematician. What was his Niels Henrik? This is Henrik. Niels Henrik Abel. Okay, he was born. Let me talk about his test. This is known as ABEL'S test. What is ABEL'S test for convergence of improper integrals? For improper integrals, convergence of first kind of improper. This is the first kind of improper integrals. First kind of improper integrals. First kind of improper integrals. Okay, this we are discussing about. First kind of improper integrals. These tests are for first kind of improper integrals. Okay, and that can be applied further. So he was born. Okay, premature. Let me talk about premature. Okay, he was a Norwegian mathematician. He was premature. Premature means before the time but mature. I mean, he was maybe of 8 months or 7 months he was born. That not known to me, but if anybody want to discuss, then go to his biography in detail. That can be found in his biography. Okay, so premature. He was born premature on August 5, 1802 in Denmark, or in Norway, at Denmark. That was Norwegian. Is okay. He was born in Denmark, okay, which is in Norway. So Denmark in Norway, and name was Nedstrand. Okay, the place was, he was born at Nedstrand. Okay, Denmark in Norway. Denmark in Norway. Okay, so at Nedstrand, this place is there. Nedstrand in Denmark, which is in Norway. Okay, so this is Norway. So he was Norwegian mathematician on August 5, 1802, and died on April 6, 1829. Very premature, in the age of 26 years and 8 months. Let me take 8 months here. Complete 8 months. 26 years, 8 months. Very okay, early death is very, I mean, due to tuberculosis he died. Okay, he was premature born. Okay, his birth was premature. Died very early. Okay, due to tuberculosis. Okay, due to tuberculosis. He was suffering from tuberculosis. So because of that, Norwegian mathematician, very great mathematician, a giant mathematician. Okay, in the field, he has done a lot of things in the field of mathematics. He was a giant mathematician. Okay, very great person. Even in this little time of his living, he has contributed a lot. Even a number of mathematicians can involve themselves for 500 years. That much contribution he has done one French mathematician, this one said this, that he has contributed a lot in the field of mathematics, so that mathematicians may involve themselves for 500 years. That is it, and he died due to tuberculosis. Okay, so this is his period of living. Now, what is the contribution of his? Now, let me talk about some of the contributions. His contributions. What are his contributions? Contributions known as ABEL'S binomial theorem. This is one of the contributions of his ABEL'S binomial theorem. Let me talk about. This is one of the contributions of his. Then ABEL'S test, which I am going to discuss about. ABEL'S theorem. ABEL'S theorem. ABEL'S group. ABEL'S group. Okay. ABEL'S irreducibility theorem. Irreducibility. Irreducibility theorem. Okay. And Abel has done. He invented elliptic functions. Elliptic functions he discussed. He invented one of the great contributions of his elliptic functions. He invented. So he was inventor of elliptic functions. Okay. So and other things, a lot of other things are there. If I just note down them, a number of things are there. Groups, functions. Okay. Then and one of the most important contributions of his question which he solved. Okay, in case of radicals. Okay, in radical functions, that is known as quintic functions or quintic equations. Okay, quintic equations he solved, which was in radicals. This question was not working, but was prevalent in those days for 350 years. Nobody could solve that. But this question, Abel solved that. Okay, within this solution, and this was one of the great contributions he contributed. In elliptic functions, he invented. He is an inventor of elliptic functions also. Okay, and Abel's test, Abel's binomial theorem, Abel's group, Abel's irreducibility. Okay, theorem. A lot of things have been contributed by him. So, a great mathematician. The field of science he was mathematics. Okay, he was a mathematician, and he was a mathematician. Norwegian mathematician. He was a mathematician from Norway. From Norway. Okay. From Norway. So he is Norwegian. So he was Norwegian. He was a Norwegian mathematician. Okay, he was mathematician from Norway. A lot of contributions of his. Now let me take what is ABEL'S test then for convergence of improper integrals. Let me discuss that. Now this is a brief introduction of his. And his father was a pastor. Okay, he was born. Okay, when his father was a pastor, his even grandfather was a pastor in a church. He was born. When he was born, according to oral tradition, he was bathed in red wine, and covered with a red cloth. This is the tradition in Christians in Norway. Okay, so that was his oral tradition in which he was bathed with red wine when he was born and covered with a red cloth. That is, Christian tradition. Traditions of every religion are not going to discuss about that. That is their own. So that is not my field of discussion. Now let me talk about. So his father was a pastor of a church, and his grandfather was also a pastor. But he worked a lot of things in poverty. He was ridden with poverty, but even then he worked a lot. So, but he died earlier. This is a tragedy for the mathematicians, okay, or for the field of mathematics, because his contributions are so many, even in its prime age or age of 26 years only. Okay, in that he has contributed a lot. So what is ABEL'S test that we discuss for now? This one. So this is integrals we are discussing about. Okay, this is improper integrals. So what is ABEL'S test? What is ABEL'S test? Let me talk about this. Okay, if a to infinity a function fx dx is convergent, okay, is convergent and bounded for x greater than a. This is x a to infinity. For x greater than a, your function fx is bounded for x greater than a. Another function gx is bounded. Okay, is bounded means its value exists within the limits. Okay, is bounded for x greater or equal to a, or x greater than equal to a. Okay, for x greater than a, and is monotonic. The function gx is monotonic. Now it can be monotonic decreasing, monotonic increasing. What is monotonic increasing, monotonic decreasing functions? That means this is monotonic function, and is monotonic decreasing or increasing. These are two kinds of functions which are monotonic increasing, decreasing or increasing. Okay, if a function, what is increasing, decreasing? Monotonic increasing. When a function is every term of a series is increasing, okay, from previous one. If I say that u1 first term is less than u2 is less than u3 is less than u4, this is u4, etc. This is known as monotonic increasing, because next term is greater than the previous term. This is monotonic increasing. This is monotonic increasing function. Monotonic increasing. And what is monotonic decreasing? Just reverse of this. If u1 is greater than u2 is greater than u3 is greater than u4, and so on. Okay, up to un. So this is monotonic decreasing. So first function is greater than second greater than third, and so on. Function is decreasing. Every term, next term is decreasing from the previous one. So this is monotonic decreasing. So this is monotonic decreasing. Monotonic increasing and decreasing functions. So here, gx function is monotonic, increasing or decreasing, is bounded, okay, or its value exists or integrable, right? Then the function then required is monotonic decreasing here. So the second function gx is monotonic, bounded, is monotonic, or its value exists for x equal to a. Then this is convergent, fx is convergent. Then a to infinity fx into gx into dx is convergent. This is the theorem given by is convergent. This is theorem known as ABEL'S test theorem. This is ABEL'S test. We have to test the convergence of two functions which are in multiplication. Okay, so through this we can test that function is either convergent or divergent. If this is not possible, the function is not bounded, its value doesn't exist, it's not convergent, it will be divergent. That is how you have to prove. So this is ABEL'S test known as this ABEL which I have described here. So ABEL gave this test for convergence of improper integrals of first kind. So this is And here the two functions which are in multiplication, fx and gx. First function fx is here, okay, is convergent already given, and this gx is monotonic, increasing or decreasing, but its value exists, is not infinite. Okay, so it is bounded, I mean. Then the multiplication of these two functions will also be convergent. It is convergent. This is known as ABEL'S test. The first test, ABEL'S test, let me talk about this. Okay, so this is known as ABEL'S test. So ABEL'S test I have discussed. Now Dirichlet's test, let me talk about. The second one, which is known as Dirichlet's test. What is that Dirichlet's test? Second, let me talk about what is Dirichlet's. About Dirichlet, I'm not going to talk about his biography. I've discussed in detail. Whenever first time a mathematician's name comes, I always talk about his biography, about his contribution in the field of mathematics. Okay, because whatever they have contributed, that is unforgettable. I cannot mince my words. Okay, that is unforgettable. We have to remember them, their contribution in the field of mathematics, so that the next generation can come to know about what are contributions of these mathematicians. Okay, so that is what I want to just mention. So whenever the first time a mathematician's name comes, I will just introduce his name, his biography, his contribution in the field of mathematics. Okay, so that is my first and foremost. And then I'll talk about his contributions. This is test. Dirichlet's test I'm going to talk about. I've talked about Dirichlet's theorem in multiple integrals time. Okay, that you can go through. If you want to know about Dirichlet's biography, then go to my tips, one of the previous lectures in case of multiple integrals. Now Dirichlet's test. What is Dirichlet's test here? Now in this case, if now here fx function is bounded, if fx, a function fx, a function fx is bounded and monotonic. Now here this is monotonic, and it's monotonic, increasing or decreasing, that is understood. Okay, is and the monotonic, and is monotonic. Fx is bounded, means its value exists in the given interval. Okay, and is monotonic for x greater than or equal to a. And a to x, a function gx into dx is convergent for x greater than a. X greater than a. Okay, dx is convergent for x greater than a, and limits a to infinity here, gx. Gx is, you may say, bounded. I'm sorry, yeah, not convergent, but bounded. Let me talk about here. It is bounded for x greater than a, and a to infinity gx into dx is convergent within this limit. Then a to infinity fx gx into gx into dx is also convergent, is convergent. Now what is the difference here between these two tests? The difference between these two tests is simple. Okay, the difference between these two tests is that in the first test, ABEL'S test, we had taken that first function fx was convergent, already given, was bounded, and second function gx was monotonic, decreasing or increasing, and was also existing for given value or for x greater than a. Now in this case, the first function fx is monotonic, bounded as well. Okay, and the gx is the second function, a to x within limits gx dx is bounded or its value exists and is convergent also. Okay, it's bounded and integrable. Let me take and integrable or bounded. Okay, within for x greater than a and a to infinity gx dx is convergent. Then the multiplication of these two functions will also be convergent. Is also then a to infinity fx gx is also convergent. Is also convergent. This is what the Dirichlet's test is here. Okay, so Dirichlet's test and ABEL'S test both are contributed to each other. First function is convergent already in case of ABEL'S test. In second case, gx second function is convergent. First function is bounded or monotonic, and in the ABEL'S test, second function was monotonic, decreasing or increasing. Okay, so that is how the functions are known as. Okay, then the whole multiplication of these two functions will be convergent. This is how we have to prove it. That is ABEL'S test and Dirichlet's test we have talked about. Now, the one which known as quotient test. Let me talk about quotient test. When two functions are in quotient form, then what is that test? That I have described in the description of the previous lecture, and I didn't discuss about that in the class study or on the board. So now let me discuss about what is the quotient test. The third one, which is known as quotient test. This is quotient test. Okay, if let me take fx a function is greater than 0, is greater or equal to 0, let me take. Okay, and gx is greater than 0, greater or equal to 0, right? And limit, let me take, limit x tend to infinity fx upon gx is equal to a, which is not equal to 0 or is not infinity, and is not infinity, either is not equal to 0, is equal to a, which is not equal to 0, is not equal to 0, or is not infinite, is not infinite, or is not equal to infinity, right? Then both fx and gx will be either convergent, or both will converge, or both will diverge. Will be convergent, and both fx and gx will be convergent or divergent, both simultaneously. That means if I take this, let me take the first function here. If fx, okay, both are fx and gx, both are positive, both are described here, and both are positive. And if fx gx within limits, gx will be convergent or divergent both. If fx upon gx, okay, fx upon gx equal to a, and if a tends to 0 and gx, the denominator gx is at limit, let me take limit x tend to infinity, gx is convergent, then this ratio, the quotient fx upon gx will also be convergent. Then fx upon gx limit x tend to infinity, limit fx upon gx will also be convergent. This is what you call quotient test. So the convergence of two functions which are in quotient form or ratio form, if the denominator is converges, okay, then the ratio will also be convergent or will converge. Okay, so the ratio will also converge then. So the quotient will converge if the denominator is convergent. Gx is converging and limit x tend to infinity. Okay, gx is convergent or converges, then fx upon gx will also be convergent. Second case, and in second case, if gx is equal to infinity or it tends to infinity, if this is b test, if a tends to infinity or fx upon gx is equal to infinity and limit x tend to infinity, gx, the denominator, is it divergent or diverges, is divergent, then limit x tend to infinity, fx upon gx will also be divergent. This is what you call either both converges or both diverges. That means if denominator is convergent, then the test will, this quotient will be convergent. If the denominator is divergent, then quotient will be divergent. So this is what you call either convergent or divergent. So both will be convergent then, or both will be divergent then, if the denominator is divergent or convergent. Okay, so that is the rule known as quotient rule, quotient test. This is quotient test. With the help of this quotient test, also we can prove that a function given or any integrand given is convergent or divergent. That is what we call quotient rule, quotient test. This is quotient test we have discussed now. Now, in case new test we will discuss when the question of that kind comes out. Okay, so that will be discussed about. There is a function which is convergent. Now let me take the questions one by one. Now, in case of first, test the convergence of, this is with the help of Dirichlet's test, let me talk about. Okay, so test the convergence of question number 1 that we now solve.